Alright guys, we're nearing the end of our unit on quadratics. We're about to start linear functions. Today, I want to go back over something we briefly touched on before the holidays, before Christmas. I want to review some things, and then I'll let you start your assignment. Several of you, there's some kids who still need to make up the quiz, so we're going to do that today too. Alright, look at number 1. When we did factoring, I never made you factor when the lead term was negative because it's trickier. And honestly, there's more than one possibility. There's usually two things that would work. They did have one the last couple of years. They had a polynomial, a trinomial they wanted you to factor that started out with a negative lead term. Now, the nice thing is it was multiple choice, so you could have just foiled all the answers till you found the pair of factors that multiply back to give this. You know what I'm talking about? Here's what you can do, though. This is what I did when I did this one. I changed this by changing all of the signs, and I factored it as if the lead term was positive, and then I knew I needed to go back and adjust something. So then I made one of my factors, I changed all the signs on one of my factors so it would go back to being negative. Okay, so for example, one thing I could do, because they would have if this were a function we were graphing, it would have the exact same zeros as this function. Do you see what I did? They would be two different functions. But if I change all the signs, then they're going to have the same zeros. So the factors are going to be closely related. This is easier to factor to me. Do you see how I changed everything, though? If it was positive, I would have changed it to negative, and vice versa. All of these happen to be negative. I changed them all to positive. To me, this is easier to factor. Okay, so then I factored this guy. I started guessing with 3x and 2x. I need 11 in the middle. 3 has to be 3 and 1, but depending on where I put it, it's either going to get doubled or tripled. And so think about it. I needed an 11. If I put the 3 here and a 1 here, look what that would give me. 2x and 9x, and they would both have to be positive. Now, this is not the question I started with, though. In my question, every single sign was different than this, because I just modified it so I could answer it. So here's how I could get this product. I change all the signs of just one of my factors. So one thing that could work would have been negative 3x minus 1. Do you see how I changed this from a positive 3x to a negative 3x, and the plus 1 became a minus 1, and I'm going to leave the other one alone. Now, if I multiply these back, it will equal this. Let's try it. That would be negative 6x squared minus 9x minus 2x, and at the end I would get minus 3, and look what I get in the middle. Negative 11. So that pair of factors would have worked. Also, I could have made this one different. I could have left the 3x plus 1 alone, and what would the other factor have become? Minus 3. That's also going to give me back this answer. That would give me negative 6x squared minus 9x minus 2x, and I get a negative 3 at the end, and I get negative 11 in the middle. Now, they wouldn't have both of those correct answers on the test. They would have one or the other. So they would have one choice down there that was correct. It would have either been negative 3x minus 1 times 2x plus 3, or this one could have been negative 2x minus 3 times 3x plus 1. They would have had one of those choices down there. And I can't imagine this being a free response because you really can't bubble that in. So if you're given this, unless I take off the answer choices, which I might do, you could guess and check. To me, guessing and checking when your lead term is negative is just trickier. So I made them all positive, got my answer, and then I just converted one of the factors' signs. Does that make sense? It doesn't matter. Now, on a multiple choice, again, they wouldn't put both of these because they're both correct. They would have one or the other. For open-ended, I would have to take either one. All right, now, domain and range. They did have domain and range with these little weird line segments. And a lot of kids got it backwards. This is what I do, because these confuse me too. Okay, but I know domain means x's, and I know range means y's. So what I do is I write out some points that are on the line segment, and that kind of helps me realize what is happening here. I'm just going to write some nice whole number points that I see, and I start to see a pattern here. What's this point right here? -4, negative 1. This point is negative 4, negative 2. This point is negative 4, 0. This point is negative 4, 1, negative 4, 2. And I'm just landing on the whole numbers. Even if I landed in between here, that x value would still be negative 4. So I start to notice a pattern. What's the same on every single place I land? In the what position? X. There's a negative 4 in every single x position. So what's the domain of this thing? Yeah, the only x value you're ever going to find on that whole picture is negative 4. It's never going to change. No matter where you land on that line segment, the x value is negative 4. Now range is a little bit different. Range is the top and the bottom. Well, the top goes on forever. But it definitely has a lowest point. And again, range is not about x's, so I don't care about the negative 4s anymore. I'm looking at the y values now. What's special about this y value? It's the lowest one you're ever going to have. This line segment's never going to go lower than a negative 2 on the y numbers. What are all the other numbers doing compared to negative 2? They're increasing. They're getting bigger. So for the range, all the y values are greater than or equal to negative 2. Okay, now you try the horizontal line segment. Do that little trick. If you were stuck on this one, find some points and write them down and see if you start to see a pattern. Even this point right here, I know it's hard to see from where you are. This point right here that's not colored in, by the way, that's important, is at 1, 3. So this point is where? 2, 3. This point is 3, 3. This point is 4, 3. Let's do domain. Domain is the x values. Are my x values all the same this time? No. The smallest x value is 1. But it's not colored in. And what are all the other x values doing compared to the 1? They're getting bigger. They're going to the right. They're getting bigger. So how would we describe that domain? X is greater than 1. Not greater than or equal to because it's not colored in. If it was colored in, then yes, I would have to put greater than or equal to. But it wasn't. All right, how about range? Yeah, this time all the y's were the same. So the y values on this whole picture, no matter where I land, whole number or not, all the y values are 3. All right, number 3, which color is a function? This one, the red one. These two, the blue one and the brown looking one, they don't pass the vertical line test. The y's are trying to repeat on those. Okay, and they wouldn't have them all in the same picture. I just was trying to conserve space here. All right, get your homework out. Let's get that graded real quick. The homework was a worksheet. Remember, I kind of explained what I expected to see. There wasn't that much to it. There was only like 5 questions. Whenever I ask you to give me a graph, though, I expect you to find some of the significant points, like the vertex and the roots and the y-intercept. You were supposed to just answer the question on number 4. It was a word problem. I mean, a multiple choice word problem. Alright, there's really not much to this, so this is what we're going to do. If you graphed it and provided me with the points I asked you for, specifically the vertex and the roots, or in this case root, that's worth 10 points. And then the answer to the question they asked is also going to be worth 10 points. On number 2, if you drew the picture, drawing in the significant parts for me, if you have the picture correct and you told me where the vertex was and you told me where the roots were, then you get 10 points for the picture. Number 2 asked 2 questions. So the first question was how high the soccer ball got. That's worth 10 points. The second question was how long does it take to get there. That's also 10 points. And then, of course, 3, 4, and 5 are just 10 points if you get the right answer. Was number 4 what? Yeah, number 4, I used the axis of symmetry and I counted over, and the best answer was 8. It wasn't perfect. It's really a little bit more than 8. Okay, since you weren't here, I'll take that. All right, questions, comments, problems. Which ones do we need to talk about? At this point, finding vertex, finding roots, that should be something you know how to do. Guys, we're almost to the end of this unit, and it's almost test time. We're going to go ahead and move on to linear functions this week. But we still have to take our test, our major exam over this. I'm not sure yet. You need to see number 1? Okay, number 1, they tell you it's about an Olympic diver, and they give you the equation. Y equals negative 3x squared plus 6x plus 24. And I need to change my window. I'm in Zoom 6 right now, but look at the window values they gave me. My x values, my time values, they're going from 0 to 10. I usually make my minimums -1 though, just so I can see the x and y axis. Okay, so my lowest time I made -1, my highest time I made 10. My x's are times. The y values, that's the heights. Look at your picture. They go from 0 to 30. I'm going to make mine -1 to 30. Oops. -1 to 30. And that way I can see a pretty good picture of what's happening here. The diver is starting way up here. Where's the diver starting? Based on the equation. He's starting at a height of 24 feet, because that's the height of the high dive. Then he's going to jump a little bit and go up into the air, and eventually, what's happening right here? Not the ground. He hits the water. He's hitting the water right here. Now, I asked you to graph it for me, and to get a good graph, I asked you to find the roots and the vertex. So I'm just going to do the vertex real quick in the calculator. I'm going to calculate maximum, and that's where it asks me for a left boundary and a right boundary. So you just got to make sure you give it a left number, or you can scroll over to the left and the right. Then it asks for a right boundary. It's going to pop those arrows up. It asks for a guess. Now it's telling me 1.0000009, 27. What's the actual vertex value? Or the x value of the vertex is actually exactly 1. So I can see the vertex is 127. I also could have done the opposite of b over 2a. The opposite of b over 2a would give me the exact x value. That's -6 over -6, which is exactly 1. So I know my vertex is at 127. I also asked you to find the zeros, so I'm going to go y equals 0, and I'm going to see where they intersect. That's at 4 seconds. He's at a height of 0. In other words, at 4 seconds, he's in the water. So I asked you to give me those two things just so you can make a nice, pretty graph for me. Then the question says, it said to graph it, which we did. How long does it take him to reach the water? Is that a vertex or a root? Yeah, that's this. How long did it take him to reach the water? 4 seconds. That's kind of like how long till the rocket landed. The x-intercept is usually where the whatever you're talking about finishes, where it ends, where it hits the water, hits the ground, whatever it is you're talking about. All right, what else? Pass those up, get out your notes. Oh, one other thing. I wanted to show you something that some kids are seeing on their calculator that looks a little weird. I want you to practice what we learned. I think it was it Thursday? Remember how we learned if you have points, you can actually find the equation? You go to stat. Everybody do that real quick with these problems. Go to stat, enter those, and find the equation. I'm just going to tell you, this is quadratic. Usually they would have to tell you what kind of function it is, or you'd have to graph the dots and see what kind of function it is. I'm telling you it's quadratic. But it gives you a weird value, and I want to make sure you understand what it is when you see this. And I really don't know why it does it on this one, but it does. Stat, edit, and you enter the points. Remember to always look for L1 and L2. When you know points but you don't know the equation, you go to Stat Edit. Always look for L1 and L2, and if they're not there, you got to reset the calculator. To me, it's easier to enter all of the x values first because it keeps you in that same column. When you hit enter, negative, oops, not negative 2, 2 comma, negative 5, negative 2, 1, negative 4, 5. Always double check yourself that you got your points lined up correctly. I always double check myself. 2, 4, negative 5, 7.5, negative 2, 0, 1, 1.5, negative 4, 4, 5, 17.5. How do I get it to tell me the equation now? Right back to stat. It all starts at stat, except we already did editing. Now we're going to do calculating. So we got to scroll over to the calculate, and I told you it's quadratic. If we didn't know, we'd have to graph the points first. But I'm just telling you it's quadratic. And then you hit enter. Yes, I want to show you what's happening here. What this is scientific notation. And honestly, the value of C is really a 0. 1.4 e to the negative 12. What that means, oopsie. Let me show you what that means. It really means you've got a decimal point followed by 11 zeros. And then 1, 4. It's scientific notation, which you probably saw in 8th grade. It's a very, very, very tiny number, and this one happens to be negative. It really doesn't matter if it's negative or positive. It's really close to 0. You see a 0? Some calculators are doing this and some aren't. I don't know why. But I just wanted to explain to you when you see this, it's usually something that's really, really close to 0. 0. So the equation would be y equals 0.5x squared plus 1x. 0.5x squared plus 1x. Do y'all remember how to get it? I just wanted to point this out because sometimes it comes up and sometimes it doesn't. Whose calculator showed 0? Just Jaquan's? Do you have a newer calculator? Okay. Anyways, I wanted to practice a couple of things. I wanted to practice that you remember where to go when you know points. And I also wanted to let you know what happens when you see that weird scientific notation. Usually it just means 0. Yeah, it's just a 0. Okay, let's also, let's go back to Zoom 6 because I want to talk about how we could have graphed those points. How do you get the calculator to graph the points that are in stat? Yes, you go to y equals, and you highlight plot 1. I'm going to take my equation out of here. This was from last period. You highlight plot 1, and then it'll graph those points for you. Now, what did we say the equation was? Y equals 0.5x squared plus 1x. And it should graph through those points. Are we good with that? How did I get the line to go through it? I put in the equation that it told me what... Remember when we went to stat, calculate, and it gave me the values of A, B, and C? Oopsie, I did the wrong thing. Stat, calculate, number 5. It gave me A, B, and then C. It gave me that weird scientific notation, which really means a number that's very, very, very close to 0. So I just used 0. So I put in y equals 0.5x squared plus 1x. I just put plus x. That's the same thing as 1x. And then not only is it graphing my points for me because I have plot highlighted, but it's also graphing the equation that it gave me because I put it in there. How do I get the plots to turn off? Because you normally don't want that highlighted when you're just doing regular calculations. Go back up there and unhighlight it. So do that. Okay, now, all of that stuff, and we did something like this last week. But I just want to again point out to you how they can take something that is so simple and make it sound so complicated. Look at this problem. If 0 is a solution to f of x equals 0, find the other solution to f of x equals 0. Right here. All they're asking you to do is find the 0. What does f of x mean? They're just asking you, where does y equal 0? Right here. They're telling you the other root. It doesn't really matter. If we look at our t-chart, they're telling me 0, 0 is also one of the roots. You see that? It wasn't showing in the t-chart that they gave us, but it is showing in the t-chart from the equation we figured out. But it was just asking us a fancy way to ask us for the other 0, which you can see right there in the t-chart. All right, moving on. Let's get our notes out of the way. It's really not that much. And I think we talked about this last semester. Parent functions. Every kind of function has a parent. And lots of times they're going to ask you to transform functions, to change their values, and to see what it does to the function. So everybody needs to be writing this down. The parent functions for all, or the parent function, we're just looking at a parabola today, not more than one. Parent function. For a parabola, for a quadratic, is y equals x squared. Usually it's the most simple, basic parabola you could make. And y equals x squared is a very simple, basic parabola. They expect you to know some things about the parent function. They expect you to know its vertex, its roots if it has any, its axis of symmetry, what it looks like. Is it considered skinny or fat? Or in other words, narrow or wide? Is it opening up? Is it opening down? So they want you to know all that stuff. And you can figure it out whether you remember it or not. You can figure it out. You do have to know y equals x squared is the parent function though. What's the value of a here? 1. What's the value of b? 0. What's the value of c? 0. Okay, keep that in mind. A, we're going to talk about a and c a lot today. The value of a does a lot of things for us. It can make us skinny or fat, and it can make us open up or open down. Okay, so it affects our width, and it affects our direction. Y equals x squared. What do you think you might be asked about? Well, I just told you what you're going to be asked about. What's something you probably need to know? Vertex. See if you can find the vertex of this guy. It's 0, 0, absolutely. And if you didn't know that, if you look at a picture of it, everybody go to Zoom 6 if you're not already. Put in y equals x squared. Now, I really caution you against telling something just from a picture. You cannot just guess from looking at a picture, especially on your calculator. But you can do the math and then look to see if it looks reasonable. What's the opposite of b? 0. 0 divided by anything is 0. So my x value of my vertex is 0. Look at my t-chart. What's across from 0? 0. So my vertex absolutely is 0, 0. You got to know that. It's the most simple vertex you could write at the origin. Does it have a root or roots? 0. Or the point 0, 0. If your vertex is actually on the x-axis, if your vertex is anywhere on the x-axis, then that's also your root. Yeah, so this absolutely has a root, and it's the same point as the vertex, 0, 0. What's the axis of symmetry? No, not just 0. X equals 0. What is that? That's the y-axis. The axis of symmetry for this happens to be the actual y-axis. So here's a pretty basic picture of a parent function. Y equals x squared. My vertex is 0, 0. My root is 0, 0. My axis of symmetry, let me draw it in red so you can see it better. The vertical line that goes straight through it happens to be the y-axis, which is x equals 0. Could I find some other points that are on it? Absolutely. Where can I look to find points? The table. Look at the table of values. If you put a 1 in for x, what do you get back for y? So the point 1, 1 is here. Negative 1, 1 is also here. If you put in a 2 for x, what do you get for y? Yeah, this is the point 24, and then across from it over here would be the point negative 24. You can always find millions of points if you know the equation. You just look at the t-chart. What's the y-intercept? Also 0. That's this number at the end, the c number. There is no c number. It's a 0. It's crossing the y-axis at 0. Its vertex is at 0, 0. Its root is a 0. Now, it probably will ask you, it'll ask you things like, how does the parent function compare to a different function? We're going to do some of those in just a minute. Okay, but I do want you to be aware of what the parent function is and that you should know all these things about it. The vertex, the axis of symmetry, the root. And if I ask you to find some points, all you got to do is look at your t-chart. Now, what we're going to look at specifically right now is how a, the value of a, and what's the value of a on the parent function? 1. How it affects a parabola. It affects the width and it affects the direction. Now, if the width is a 1, we're going to just call that neutral. So if you were asked to describe the width here, it's neutral. It's not considered skinny or fat. It's kind of right in the middle. Now, as we start changing that width from something different than a 1, it's either going to get skinnier or fatter. We did talk about this, didn't we? So, in your calculators, we're going to talk about what a does. I want you to keep y equals x squared in there. But I also want you to graph y equals 3x squared. And we're going to see what happened to the parent function when I change the value of a to from a 1 to a 3. What do you think is going to happen? Yes, most kids first think it's going to get wider, but it actually doesn't get wider. It gets more narrow because it's rising faster. Okay, so there's y equals x squared. Here comes y equals 3x squared. Do you see how it got more narrow? All right, now, what do you think if I changed it to y equals negative 3x squared? Yeah, it still got narrower from the y equals x squared, but it also flipped upside down. Okay, so think about that. A controls direction and width. Okay, so we talked about how to make it skinnier. We made it from a 1 to a 3 or from a 1 to a negative 3. The negative 3 made it skinny and it did something else. It also flipped it upside down. How do you think I can make it fatter? Let's take out the 3x squared. Okay, a decimal number, but 1.5 is going to make it, it's going to make it skinnier still. So yeah, I agree with the decimal number, but you have to be more specific. It has to be a decimal that's less than 1 or a fraction that's less than 1. Fractions make it fat. 1.5 is still bigger than 1. You see what I'm saying? It's a decimal, but it's still bigger than 1. When you get bigger than 1, you actually get skinnier. When a gets bigger than 1, it gets skinnier. And 1.5 is bigger than 1. Give me something smaller than 1. 0.5 x squared. 0.5 x squared. Now that should make it fatter. There comes y equals x squared. Here comes y equals half x squared or 0.5 x squared. It gets wider. Okay, so let's think about that because there's two things happening here. You really need to talk about the absolute value of a. The sign does not affect the width at all. What does the sign do? It changes its direction. Exactly. But if you just look at the value of a, not the sign, but just the number. If it's bigger than 1, then it makes it more narrow. If the absolute value of a is smaller than 1, like a fraction, like 1/2, 0.5, 1/3, 1/4, 2/5, that's when it's going to get more wide. And if the absolute value of a equals 1, that means either a 1 or a negative 1. Then we just call that neutral. We don't call it skinny or fat. It's just kind of right in the middle. Now, what about if a is negative, though? What does the negative do? It just opens down instead of up. That's all the negative does. The negative doesn't affect the width. The negative just affects the way it opens. It's going to open down. It's going to be a frown instead of a smile. If A is positive, then we say that that is opening up. A smile. Are you with me? So that's what A controls. That's one of the biggest transformations that you've got to know about. What does A do to a function? It makes it skinny or fat, and it makes it open up or down. All right, everybody sitting at your desk, show me with your arms. Everybody better do this, or we're going to have double homework. Show me y equals x squared. Kind of right in the middle here. Now, what are your arms going to do if I make it y equals 5x squared? Going to get super, super skinny. All right, go back to y equals x squared. What about y equals 1/2 x squared? You're going to get nice and fat. Go back to y equals x squared. Show me y equals negative 5x squared. You're going to go down, open down, and get skinny. Down and skinny. Go back to y equals x squared. All right, I'm going to throw something at you we haven't talked about yet. What about y equals x squared plus 1? No, your arms shouldn't change. You just need to go up. Okay, so let's talk about that next. What does y-intercept do? What does the c do? Y equals x squared compared to y equals x squared plus 5. What do you think is going to happen there? Does it affect the width? There's y equals x squared. What's going to happen to y equals x squared plus 5? The whole thing is going to go up 5 spaces. Is it going to get skinnier or fatter? Not at all. So y-intercept changes. Just move a function up or down. All right, I'm going to give you a function, y equals 2x squared plus 3, and I want to compare that to y equals negative 2x squared minus 5. How would these two things compare? Let's say this is my first function, and then I changed it to this one. It's going to go down instead of up. It's going to open down. That's not going to move down 5 spaces. It's going to move down 8 spaces. This one would be, the y-intercept would be 8 spaces below. This one's at 3. Here's my y-axis. If this y-intercept is at 3 and the other y-intercept is at negative 5, how many spaces down did it go? It went down 8 spaces. So not only is it going to flip, is it going to change widths? No. Would we call this neutral, wide, or narrow? Both of these will be narrow, because they got bigger than 1. The absolute value got bigger than 1. And this one's opening down just because it's negative. So basically, that's what I want you to take away from today. I want you to understand the parent function. What's the vertex of the parent function? 0, 0. What's the root of the parent function? 0, or 0, 0. What's the axis of symmetry? X equals 0. What's the width? Neutral. It's got a width of 1. Okay, and if I start changing width and I start changing y-intercept, you should know how that affects the graph. Alright, we are going to do both sides, and it's not that much, I promise, folks. Plus, I'm going to do a couple of them with you. First, let's look at practice A side. (9-4) practice A, where it says order the functions from narrowest graph to widest graph. Are you with me? Look at number 1. It says f of x equals 5x squared. And then it has a different function. They called it g of x. That just means the same thing as y. It's just they're just to show you two different functions. G of x equals 2x squared. Which one's going to be they want us to put narrowest to widest. Which one's going to be the skinniest? Yeah, this one is. You could just put f of x. So on my answer line, f of x is the skinniest, the narrowest, and what's the next one? G of x. They're both on the narrow side, but how do I know this one is more narrow? Because it's a bigger number. The bigger you get from one, the more narrow you're going to get. And if you weren't sure, then graph them together and compare them. First, I'm going to look at 5x squared. And that's pretty skinny. And then I'm going to look at 2x squared. Also skinny, but not as skinny. And again, we're always comparing that back to the parent function of y equals 1x squared. And 1x squared is what we're going to call neutral. The bigger you get than 1, the more skinny you get. The smaller than 1, regardless of the sign, the fatter you get. Okay, so good question. Number 2. The second one says f of x equals 1/2 x squared. G of x equals negative 3x squared. And h of x equals x squared. Okay, this is why we talked about the absolute value of a, because the negative 3 is really smaller than 1, right? But when we're talking about width, you take the negative sign off and you just think about the 3. So what's the skinniest one going to be here? G of x is the skinniest. Okay, now what does the negative sign do to it? It also makes it go down, but this one's just going down, but it's also down and skinny. What's the next narrowest? H of x, the parent function. And what's the fattest? F of x. Does that make sense? All right, now look at so we did 1 and 2 together, really. Look at number 3. It's going to give you a function, g of x equals x squared minus 3. And it asks you to compare it with do you see how the directions here are all the same? Compare it with the graph of f of x equals x squared. They're wanting you to compare it back to its parent. So width, how would the width compare? Neutral, it's the same width. Does it open up or down? Up. What's different about it than the parent? The vertex. The vertex is not at 0, 0 anymore. The whole thing went down 3 spaces. You can figure out the vertex mathematically. Sometimes you can kind of think about it common sense wise. If we took y equals x squared and changed it to y equals x squared, isn't it minus 3? Ah. Oh my gosh. Clear? Okay, y equals x squared minus 3. Let me take this one out of there. Think about it. The y-intercept the vertex was at 0, 0. And we know the whole thing had to go down 3 spaces. So where do you think it's at now? 0, negative 3. And if we mathematically figured that out, it would be 0, negative 3. Okay, so that's all you're doing on this side. Then number 7 is kind of like another problem where I want you to practice changing your window. Look at my time values. They go from 0 to 5. Look at my height values. They go from 0 to 450. So you're going to have to adjust your window. You're going to have to... this is about blocks being dropped from different heights. So your graph's going to look something like this. And just read the setup and sketch the graph and answer the questions. Okay, now flip it over to the back because I do want to talk to you about the back. I listed, this is practice B, 9-5. Are y'all with me? Do you see where I wrote in the things I want you to find? Vertex, axis of symmetry, roots, and then I ask you to graph it. They give you a space to graph it, right? Let's do the first one together. For these, you can be in Zoom 6. But not all of them are set up yet. To graph a function, it needs to be in the form y equals. Look at number 1. Number 1 is ready to go. X squared minus 6x plus 9 equals y. That one's ready to go. Look at number 2, though. Number 2 says x squared equals 4 plus y. That's not ready to graph yet. Yeah, you got to get y all by itself. So that means you got to make that 4 go away. You got to move it to the other side. So what would this one be? Y equals x squared minus 4. Real quick, look at number 3. 2x squared plus 4x equals 6 plus y. What's got to move here? The 6 needs to come over here, and it's going to become what? a minus 6, so it won't be on this side anymore. And also look at number 4. X squared equals 5x minus 10 plus y. A bunch of stuff's got to move here. Yeah, you want y to be by itself, so you got to move the 5x. It's going to become minus 5x, and what else? Plus 10 equals y. You can put y in the front, absolutely. Now, first period asked me to do this first one with them. Y equals x squared minus 6x plus 9. How do you find the vertex? Opposite of b over 2a, and then look in the t-chart to find the y that goes with it. So let's find the vertex. Opposite of b would be positive 6 over 2 times 1. What's the x value of my vertex? 3. How am I going to find the y? Just look at the t-chart. Okay, so let me put my function in. Y equals x squared minus 6x plus 9. I already figured out with my brain that the x value of the vertex is 3. So now I'm going to look at the table of values. And what's the y value? 0. So I can come over here and put a dot at 3, 0, and I can label that vertex. What's my axis of symmetry? Not just 3. X equals 3. And I would like you to draw that imaginary vertical line, and you can label it on the graph if you want to, or list it on the bottom. That's x equals 3. What's my one and only root here? 3, 0. The root and the vertex were the same question. How do I know that this is a root also? Because the y value is a 0. A root's when the y value is 0. So it just so happens if your vertex is on the x-axis, guys, then that's also your one and only root. So I just wrote it twice. Once so I know that you know that's the vertex, and I also label it as my root because it's my one and only root. Now, it's really hard to draw a nice picture with one point. What's another point I know right away? Just by looking at the equation. The y-intercept is 9. So I'm going to go up to the y-intercept and put a dot at 9. And then I can use my axis of symmetry to figure out the other point that goes over here, and then that's probably pretty good enough to... I want you to draw the parabola too. So you can either label everything for me on the picture or label it down there in the... You see that line they give you underneath? Just be real neat about it. So on that line you could put... you don't have to write out the whole word vertex, but you could put V is 3, 0. A of S is x equals 3. Root is also 3, 0. You can list all the things I asked for, and then of course in the picture I want to see all that stuff. The x, all that good stuff. Okay, so that's all you're doing. Vertex and roots, guys, you've got to be experts at that. That's a huge part of parabolas. And then again, they give you another question at the bottom where you got to change your window and answer the question that they're... How do I do number what? What do you mean, how do I do number 2? Okay, but that I just told you how to change those. We went through how to change all of those questions. That would be y equals x squared minus 4. You need to get y by itself. Yes. Hold on one second. All right, so that's your homework, both sides.